Hello. Welcome to my talk on RABIT, our new mechanism that supports efficient random queries by using bitmap indexing. My name is Junchang, and this is a joint work with Xiao and Manos. A quick introduction to bitmap indexing. In its basic form, bitmap indexes using equality encoding scheme represents the contents of an indexed column by using multiple bit vectors, one for each unique value of the domain. In this example, the indexed column has 10 distinct values, so the corresponding equality encoded bitmap will have 10 bit vectors. Bitmap indexing is fast for point queries. For example, for the query AX to 5, we can simply fetch the fifth bit vector and return it as the query result. However, equality encoded bitmap is inefficient for random queries because now you must merge a group of bit vectors before returning the result. To address this performance issue, people commonly use more sophisticated encoding schemes like range encoding. For range encoding, for a tuple value v, if the domain value b of a bit vector satisfies a given predicate, the corresponding bit of this bit vector is set to 1. Range encoding is efficient for range queries because now you can simply retrieve a single bit vector and return it as the range query result. However, range encoded bitmap has several drawbacks. The first is that the bit vectors in the middle range are barely compressible because each bit vector has a moderate number of ones. The second drawback is that update in range encoded bitmap flip bits in a high number of bit vectors, which is becoming a bigger bottleneck for higher cardinality attribute. The third drawback is that every insert will set the bit of the last bit vector, incurring high contention on it. To address these issues, we present a new encoding scheme for efficient random queries on frequently updated high cardinality attributes. It is called group encoding. The basic of group encoding is point bit vectors, which are similar to the bit vectors in equality encoded bitmap. Further, we partition these bit vectors into groups, and for each group, we add a cumulative bit vector. These cumulative bit vectors can significantly accelerate range queries. Group encoding has several nice features. The first is that it is efficient for range queries because now for each range query, we only need to merge a few cumulative bit vectors along with a few point bit vectors only in the boundary groups. In this example, for this range query, we only merge 2 bit vectors, which is much faster compared to merging a group of bit vectors in equality encoded bitmap. Furthermore, group encoding is update friendly because each update flips at most 4 bits. In this example, if we want to change the 7th row from value 9 to 0, we only update these 4 bits, which are orders of magnitude lower than updating range encoded bitmap. The third benefit is that group encoding is space efficient because the major body of it is still point bit vectors, which are highly compressible because each bit vector contains only a few ones. Overall, group encoding is space efficient, update friendly, and good for both point and range queries. We evaluate RABIT and the group encoding by integrating it into DuckDB. Overall, our evaluation shows that group encoding can help accelerate range queries. Overall, we are pushing a bitmap toward general secondary indexes. And if you are interested, please contact us. Thank you.